All right, folks, we're going to work through lesson 2 in your packet today, which is about function notation. And I just want to explain before we get into it why we use this weird notation. It takes a couple of tries to get wrap our brains around. Once we get it, it's really useful. So we looked at in the last lesson that equation that said y equals 2 times the input minus 1. And we decided we could write that equation as 2x minus 1. Y equals 2x minus 1, which is great. And I could ask you to find y when x is 3. And you could do y equals 2 times 3 minus 1. I could also ask you to find y when x is 19. You would do 2 times 19 minus 1. Y equals 2 times 19 minus 1. I could ask you to find y when x is negative 20. You would do y equals 2 times negative 20 minus 1. If you told me out of the blue that y was 15, I would believe you, but I wouldn't know what the input was that gave you that output. Also, it's a whole lot of words. You know mathematicians don't like to write out things like that. It's a whole lot of words. We like shorter notation. So somebody invented this, what we call function notation. And it looks a little weird, but it's actually really useful. So here's an example. This is the exact same equation as you saw a minute ago, except instead of saying y equals, we write this. We write, and we read this as f of x. F of x equals 2x minus 1. What that means is the function, we'll call it f. F is just its name. Could be g, could be h, could be Imogene, we don't care. This function's name, we'll call it f, f for function. The function evaluated at x is equal to 2x minus 1. And what that allows us to do is I can write this kind of shorthand. If I write f of 5, that means the function evaluated when x is 5. And what I do is everywhere there's an x in the function, I replace that x with the 5. And then I get my answer. My answer would be 2 times 5 is 10 minus 1 would be 9. Takes a few tries to get our brains around this, but once we get it, it's short, useful notation. If I wanted you to find out the value of the function when x was 10, I could write those words out, or I could say find f of 10. That means find the value of that function when x is 10. I do 2 times the input, that 10, and I take away 1, and I get 19. So it's new notation. We read that again as f of x. Some people say f at x, but usually we say f of x. Okay, and here are 3 different functions, and they're asking you for different values. They've named this first one f of x, as I did. They're calling it f. Second one they're calling g, and the third one they're calling h, and those letters don't matter at all. It's just the name of the function. So it says for each of the following functions, find the outputs for the given inputs. F of 2 means to find the value of this function when x is 2. So when the input is 2, find the output. Well, everywhere there's an x, I'm going to replace it with a 2. 3 times 2 is 6 plus 7 is 13. So my answer there is 13. F of negative 3 would be 3 times negative 3 plus 7, which is negative 9 plus 7 would be negative 2, is my answer. So we're evaluating that function at a given value. If I go to the next one is asking about the function g of x. So it says find g of 20. So we have a division problem here, that's no problem. This would say take 20, subtract 6, and divide by 2. 20 minus 6, that's 14 divided by 2, would be 7. G of 0 would be 0 minus 6, divided by 2 would be negative 3. Functions can look like anything. This third one has a square root in it. That's okay, we can do square roots. This says, this one they called h, evaluate h when x is 4. Evaluate this function when x is 4. So the square root of, we haven't done much with square roots, but let's see where this takes us. 2 times 4 plus 1. Well, 2 times 4 is 8 plus 1 is 9. Oh, the square root of 9 is 3. H of 0 would be square root of 2 times 0, which is 0, plus 1. Square root of 1 happens to be 1. So it's substituting in for a value of x and coming up with the output. Just as a reminder, remember that little QR code. If you don't like my video, you want to watch that one instead, you may absolutely do that. Right down below here, the next question, it says, given this function, so f of x equals this, do the following. First part says, explain what the function rule does to convert the input to the output. So what's happening to the x? And this is kind of asking you about order of operations. When you input the x, what happens first? Do we add that 7 first? Do we divide the 3 first? So the way that's written, what they want you to say here is that the input is divided by 3, and then we add 7. Okay, so it's asking you really about order of operations. Can you evaluate f of 6 and f of negative 9? Well, let's see. F of 6 would be 6 over 3 plus 7, which would be 2 plus 7, which would be 9. F of negative 9, we would put in the negative 9 for x. Negative 9 divided by 3 plus 7. Negative 9 divided by 3 is negative 3 plus 7 would be 4. We're looking for the output, so we're looking for a final answer there. Part C says, can we find the input for which the output is 13? Well, the output, remember, is this part. If this thing is 13, what value for the x gives us the input? So let's see, if 13 is the output, I'm looking for the x. Well, now I just have an equation to solve, right? I could subtract the 7. 6 is equal to some number divided by 3. I know that number is going to be 18. My algebra to solve that would be multiply both sides by 3. And I would get x equals 18. So if I try that input of 18, 18 divided by 3 is 6 plus 7 gives me that 13. Here's an interesting question, this next one. It says, if g of x is 2 times f of x minus 1, what is g of 6? Wow. So that's got a g and an f at the same time. But we can do this. G of x, we're looking for g of 6. That would be equal to 2 times f of 6, because everywhere there's that x, I'm going to replace it. 2 times f of 6, and then take away 1. This question, the confusing part about this question is that it's still referring back to this f of x. So what I'm going to do first is figure out what's f of 6. And actually, we already did that. That was this, right? We've already done that part of the problem. So g of 6 would be 2 times that 9, and then take away 1. 2 times 9 is 18, minus 1 would be 17. So it's okay to have a function within a function. Again, the more difficult part of this question that students always miss every year is that we're referring back to that same f of x we just had a minute ago. So we're talking functions again, and our function could be a table that we're looking at. Recall that all function rules come in either equations or graphs or tables. Here's a function with a table, right? It says boiling water at 212 degrees Fahrenheit is left in a room that is 65 degrees Fahrenheit and begins to cool. Temperature readings are taken each hour and given in the table below. In this scenario, the temperature is a function of the number of hours. So the question says evaluate T of 2 and T of 6. That means find the temperature after 2 hours. When I look at my table, my input is 2. My output would be 104. So T of 2 would equal 104. And T of 6 would mean what's the temperature after 6 hours? T of 6 would equal that 68. Part B says, for what value of H is T of H 76? So that's when is the temperature 76? After how many hours? So we're looking for the input now, given the output of 76, and we look at the table. H would equal 4 for 4 hours. Next question says, between which two consecutive hours will T of H equal 100? Well, let's see, 100 is not in my graph here, right? 100 is not in the table. But if I look up here, between which two consecutive hours would it be 100? Well, that would be between hours 2 and 3. Okay, so we can read a table, read inputs, and read outputs. Now here's another question about these inputs, outputs. Now we're given a graph, so no table, no equation. This is called a piecewise linear function. It's made up of a bunch of little line segments together. And it says evaluate the following. So let's see, f of 1. What is f of 1? Well, that graph is the function. This graph is our function. So when it's saying what's f of 1, I'm going to look at when x is 1, what's the y value? So I'm just going to go over to 1 in the x direction and look up. When x is 1, y is 1, 2, 3, 4. That's my answer. What's f of negative 3? I'm going to backtrack 1, 2, 3 and look down at that graph. That would be negative 4. Find f of 5. I'd go over 1, 2, 3, 4, 5 and look down. That would be negative 2. You guys find what f of 0 is for me. And then we'll just look at this last question. It says solve each of the following values for of the input x that makes them true. So the next question is going backwards. What are the inputs when the outputs are 0? So I'm going to glance at that graph and figure out when are the outputs 0? When are the y values 0? That would be when x is negative 1, when x is 4, and when x is 7. So when x would equal negative 1 and 4 and 7 for that question. The next part says do the same thing, only figure out what it is when y is 2, when the output is 2. If I draw a little horizontal line through here, I can kind of see that would be when x is 0, and also when x equals 3. Next question says, what is the largest output achieved by the function? The largest output would be 4. And then it says, at what x value is it hit or is it achieved? Largest output would be 4, and it's achieved when x is 1. So the input would be 1, the output would be 4. Or I could answer this part as 4 and this part as 1. All right, so we'll work through those the homework questions, and that's it for today. All right, bye-bye. So work through those homework problems on the next page, and then be sure you circle any questions you're not sure on, and we'll talk about them on Monday. Okay, there might be a few that are a little weird. We'll talk about them Monday. Have a great weekend, guys. Bye-bye.